Hello, welcome to the Mo-Sys LiveLab webinar. Today we're going to talk about the V70 tracking kit and what you can do with it. Before we start, just a bit of housekeeping. The webinar will be 60 minutes long. We have planned 40 minutes for presentations and then 20 minutes, 15 to 20 minutes for the Q&A. Which brings me to the next point, Q&A. There will be a Q&A at the end. If you have any questions for our speakers or for us, use the Q&A feature at the bottom of your screen in Zoom. You have a button called Q&A, so you just click on it and you can type in your questions and we're going to answer them. Also, the webinar will be recorded, so at a later point, if at any point the quality drops or the video is jittery, we record it in high definition, so you can play it back and watch it again or share the link. So we're going to share it at the end of the week, hopefully. Okay, so as I said, we're going to talk about the V70 tracking kit. And sound. Okay. Oh, getting an echo. Sorry about that. One second. I'm not sure. Can you hear the echo?
Yeah.
I apologize.
Just sounds a bit bigger.
Stop share. Let's try again. Let's mute it.
We're in a small control room.
Yeah.
Sounds like a massive room.
I think it's because we have an echo here. Let's try that again. Share it without the sound. Okay, I think that's better. You can still hear me and you can see the slides. Apologies for that. So yeah, LiveLab TechTalk, we're going to talk about the V70 kit. We invited 4 excellent speakers. We have 5 excellent speakers. We have Michael from Mo-Sys, the CEO. We have Carlos Castancanete from Canon. We have Andy Blondin, Technical Product Manager from Epic Games. And we have Jerry Spivak and Eric Ladd from Standing Room Only Simulations. We're going to start with Michael, who's going to talk about Mo-Sys and the V70 kit.
Hello, everybody. Welcome to yet another webinar. We're sort of starting to introduce our products bit by bit and found during COVID times, actually, that really suits us. And it's a way to reach out to everybody and inform of our products. Now, this webinar we talk about AR graphics or sports graphics in particular, and this suddenly becomes to quite a big fame during COVID times, but as well, I mean, it's an old way of adding or spicing up broadcast with 3D graphics, but now during COVID times it becomes more and more popular also through the need of for example, covering up empty seats in stadiums. And I mean, everybody is thinking about how can we do this. If you just do a Google search on virtual audience stadium, you end up for the last month just with 17 pages. So it's really a hot issue and everybody's thinking about what to do. I personally think it's going to go beyond virtual audience, because why do you want to see fake audience when there is no real audience? And I think it's just the beginning of a lot of creativity, and think about what you can do with that space. And we'll come to that. I think we've got some cool pictures there. Yeah. So Mo-Sys, we operate in the film as well in the broadcast market. We ship into about 50 countries and have installation globally and in all the big broadcasters globally. And I think there's just a fraction of the logos that we could put there. We started off with camera heads and robotics. Initially, we actually started off with motion control systems. And motion control needs to be super accurate. There's not allowed to be any backlash and play. And that's where we come from, that position, and sort of relate that to the broadcast industry with our remote heads. And then we went into tracking. And I will later sort of explain or demonstrate the AR graphics side on a project we were actually pretty proud of. But let's have a look first what other people do. Okay, some add posters, or you can print out people, fans, into the empty spaces. I think somewhere in Korea as well they used inflatable sex dolls. I think we see a picture of that. So there are definitely lots of different solutions out there, and what we propose is not the only one. So I just referred to a project we were actually very proud of. It was a couple of years ago, so AR isn't that new. It was the Red Bull Air Race, and we actually had time to sort of look for new ways of tracking, and it was quite a nice experience actually to work with those guys. But we actually had 3 types of tracking implemented there, and I will get to the V70 last. Yeah. So what we had there is our remote heads. We have like it's called the L40, now followed by the U50 as well, which is for super long block lenses remote head. And these remote heads also put out data for tracking, so you can follow. In that particular case, we actually made it twice as fast as the normal version. Because those planes are pretty quick, we're going to see a video later on. The other system, the second one, was what we call Gyro tracker. You see that box on top of the box lens, and that is actually a super sensitive box that registered any movement accurate enough to track with a 1000mm lens to, I think, a 10,000th of a degree accurate enough for, I think it was 10-15 minutes or something like that. The challenge there was that you have on the Red Bull Air Race, you have tiny little planes flying, let's say, through blue sky. You will not see their speed or nothing. So you need actually to look down on them so that they go across the ground, and they see the ground as a reference, and you see how fast they can go. And they're a bit mad. I mean, it's, so the solution was the cameras are on cherry pickers. They are 50 meters of 150 feet high, and you sort of wobbling in midair, and as you can see here on the left, it's quite a wobbly thing, but yet you have to provide a tracking accuracy that you can overlay augmented graphics into the real environment. And we sort of used a box with super nearly military grade gyros in there. It took us 6 months to develop that, and we at the end did what is actually flying Airbuses around the world. Here you see now the yellow crosshair on a fence that is so really zoomed in, and it actually stays with that. And if we zoom back out, you see our test construction, which was car inner tubes, and we're sort of wobbling around while actually keeping the yellow crosshair exactly on that fence. Here's the whole thing then a few months later in operation, and you will see in a second those mad planes flying across. And the exercise was to provide additional information about the competition as AR graphics. I quite like that project that was done together with VisOT. And yeah, so they go around several times through that circle, and the numbers of those gates keep incrementing automatically. They are mad. Okay. Oh, here's another thing, just to sort of demonstrate that sensitivity that we reached. This is actually the, can you just stop for a second? This is, you see the round circle, which is the graphics. And the little dots are windows on some skyscraper, I think 3 or 4 kilometers away. So we zoomed all the way in with the extender, and then we trembled with our fingers a little bit on the hood of the lens, which is normally unencoded motion. No remote head or no tracking head would ever register that. And we trembled just with the fingers on the case and the hood of the lens, and you can see that at 3-4 kilometers distance, actually, this circle stays pretty close. Now we're zooming out, you're zooming back, and you see how far away that thing was. The same situation, we're actually on those inner tubes and cars to bobble this whole thing. Once more, the remote head also providing tracking. And in our last webinar, we introduced the U50, which is sort of U-shaped, so both sides remote head, and that actually provides even stronger capabilities to cope with the very, very, very long lenses. So now we come to the V70, and the V70 is special in the sense of it is, V70 stands for Vinton Vector 700 series or 750. It's a 7 series, and that is one of the most popular heavy-duty pan and tilt heads around. And when you are on these sports events, you don't want to necessarily conflict with the people who rent out or provide these heads. As they provide cameras and tripods and all those things. So we created a kit that you can bolt on within minutes onto those heads, so to keep everybody happy. And it went through several generations. The first generation was with a belt, as you can see in the top picture. But belts do need some technical understanding. They shouldn't be too tight, they shouldn't be too loose, because then they have unencoded motion and backlash. Then the second generation, we went to zero backlash gear wheels, and you can see, I don't know if you can see the sort of brass wheels. They were split and a spring in the middle, and they make sure that there's no play, no backlash between them, but as well, it's such a mechanical, it was sensitive, and we wanted to have something that is really, really robust. You can just simply bolt on. And then comes the third generation now, where we can, where the pan unit is simply bolted on like you normally do with a 4 sort of Vinton bolts, and there is no belt, there is no gear, nothing, it's all included. And I think it resolves something like 4 million increments per revolution, so it's super accurate, but robust, and it doesn't get damaged, and it doesn't need belts tensioning or loosening. Somebody who has done it before probably mounts this kit within 5 or 10 minutes. It's a few screws, I think it's also 7 screws you bolt on, and that's it. So we tried an animation. So very simply, it's 3 parts in a way. They come together, and that's it. You're ready to go and ready to shoot. All of this is absolute encoding and without any gears. Gears normally in encoders create backlash. That's why we don't have gears in there. And they're absolute. So if you switch them off and back on, they do know, the encoders know where they are. So once more we see the arrays. So now with what they call the ghost. So you have a virtual against the current one, because if one plane is flying, you don't have a relationship and understanding of its sort of competitiveness. So that's why an earlier one is sort of ghosted onto it. Yeah.
Okay, thank you, Michael. Yep. So we've seen the Canon 100 times lens that we used for the Red Bull Air Race and for the tests, internal tests. Let's talk to Carlos from Canon about this. Oh, Carlos.
Hi. Good evening, everyone. Can you hear me?
Yeah, we can hear you.
Yeah. Okay. Hello. So thanks for the explanation, Michael. The second part, or one part that is also very important in order to tracking all these movements, is not only the part of the tripod, because you can control the pan and the tilt, but all we know that it's very important also to have information about the zoom and the focus in order to follow all the images and to receive all the information from the lenses and send the information back to the Mo-Sys box in order to be able to have the right tracking of the images. For that, I have prepared one small presentation in order to explain exactly what happened from the lens and how the lens is taking this information and sending back to the Mo-Sys box. We are working together with Mo-Sys. We are collaborating in order to get the maximum compatibility between the lens, the Canon lenses, and the Mo-Sys system, and to have really big, accurate information about the movements. So let me share my screen. Can you see it now?
Yep, we can see it.
Okay. So first of all, let me introduce myself in order to give you a little bit information about my background and my history in the company. I have been working in Canon for 23 years, and the last 15 years I have been working in the first 15 years I was working in the technical service for broadcast lenses. So I used to be a service engineer, and in that moment, after these 15 years, I moved to sales, and after 2 or 3 years I became the general manager for the broadcast division, and right now I'm taking care of broadcast lenses, but also thinner lenses and HDR displays. Here you can see my email address. If you, after the presentation, you have some questions, I can give you an answer in the Q&A part of the presentation, or you can send some mails to me without no problem. The lenses that we have been seeing in the presentation, in the previous presentation from Michael, was 100 times, and right now they are using 66 times, also for the tests that we will see later. And all this family of lenses, all of them has the possibility, or they have built in some encoder devices inside. All the box lenses and the small lenses as well, and we can take the information from these encoders directly from one port, one 20-pin connector, in a very easy way. So this is perfect to work together with the Mo-Sys box, and they receive all the information from this 20-pin connector. All these lenses are broadcast lenses to be used in 2/3-inch sensor cameras, the classical broadcast cameras. But we also have a family of lenses that are ready to work with large format sensor cameras. So we can also work with Super 35 sensor cameras with these different lenses with EF mount or PL mount. We have a large product range or cinema lenses, but only these 3 models also mount this drive unit that is exactly the same drive unit that we used to use in the broadcast lenses. And the big advantage is that we can use these lenses with or without the drive unit. You can see it in the image on the right. But the big advantage is that if we are going to use one cinema lens without any drive unit, we need to use external encoders. So this makes the configuration a little bit more complicated. But by using these servo lenses, we can work with large format cameras, but at the same time, we can have these small encoders inside the drive unit, and we can take all the tracking information for zoom, focus, and iris. In case of using the small lenses for 2/3 inch or for Super 35 cameras, we will find this 20-pin connector on the lenses, and we can use the lens in 2 different ways. You can see here in this diagram in the right that we are able to work in the normal way or in a virtual way. In the configuration, to decide which way we want to work, the only thing we have to do is to change the pin number 19. And if we are using the pin number 19 in open, we will be working in a normal way. So that means that we will receive the follow signal in the classical way. So it's an analog follow signal for zoom, focus, and iris, but also digital information from pin number 15 to pin number 18. But if we want to take the raw signal from the encoders, then we need to work in virtual. And in that way, we will need to change the configuration of pin number 19 and shortcut this pin to pin number 20, that is GND. And by only doing this, we will be working in virtual, and we will have the raw signal from the encoders directly to the device, to the Mo-Sys box. And these encoders they have a very good resolution. It's a 16 bits resolution encoder. So that means that we will have accuracy enough for the tracking of the images. And at the same time, we also use a special mechanical system in order to have also 0 backlags in the mechanical part by using a double gear with a spring in the middle. And in that way, we will not have any play or backlash from the gears, and working together with these 16 bits encoders, we will reach this very high accuracy. This is an example of the encoders that we used to use in our drive units. It's a Canon patent, and as you can see, it's a very, very small device. That's why we are able to use these encoders from inside the drive unit, saving space and make the configuration much more easier. And as you can see, the side of the encoder is almost the same size as one coin. And we will reach this 16-bit resolution. When we use the tracking with box-type lenses, like in the example that Michael showed us before, we also have this possibility to use the encoders. You can see here in the image with the red cycles, the encoder for focus and zoom in the bottom side of the lens. And on the right side, you can see the 20-pin connector. So it's quite easy to take out all the information and mount the lenses together with the Mo-Sys system and to be able to get these high-quality images. I think that's all from my side. So I will be able to answer any question from you in the Q&A. Thank you very much.
Thank you, Carlos. Thank you. Yeah, if you have any questions for Carlos, please feel free to use the Q&A feature in Zoom. Okay, so these lenses, if you want to use them with virtual, you have to calibrate those lenses, and Michael is going to talk about our lens calibration.
Carlos, it keeps looking very, very interested if you sort of look under the hood of those big box lenses. Yeah, well, like you also said, that you have a sort of split encoder wheel. We do the same on the wheels on the outside. If a lens doesn't have internal encoding, which we prefer it does, it makes life much easier rather than bolting things on the outside. But we also have external encoders that we can put onto the outside, but also they are our third generation spring loaded, so to reduce the backlash between the gears. And especially older box lenses, we always find a way to encode a lens. So worst case scenario, send it to us and we find if it's just a unique thing. Okay, but you need to calibrate. The whole point of having lens encoding is that you can measure the distortion or the particular parameters of a lens for every focus and every zoom position. And you run through a procedure of different zoom positions, and at each of the zoom position, you go through different focus positions. And that gives you a matrix of these parameters of the lens and the distortion. And you want to measure that so that you can compensate or actually adapt and match the virtual image accordingly. Interesting enough that we prefer the analog and distorted world to the perfect square computer world, and we're actually distorting the perfect world to match the analog. That's what we're used to, that's what we expect, and that looks in a way the nicest. So, but we measure that, and we came up with a way of doing that very, very precisely. We actually place 3 LED strips in 3 different colors, one close, one mid-range, and one far away in front of the lens. And we just have a pan movement, and with that pan movement striking across, we actually take images of all these LED strips. And what you see there is actually, these are little dots, and there are maybe 200 little dots on each of those sticks. And together, they give us the information with about 1.5 to 2 million samples per calibration. So a zoom lens has between 1.5 and 2 million samples, and these samples are super, super, super small. That's why we used LEDs. Even if they're so small, you can see them because they light out. Then we find the center of those circles. The image here definitely hasn't got to the right center. And we also sort of put it in sort of reversed colored LED into the middle, and there's a hell of a lot of mathematics involved to actually automate that process and end up with the right distortion measurement that we do. So our lens calibration is a 2-phase project, or it has 2 phases. So the first phase is we utilize those LED strips to basically get the, we call it the base file of a particular lens type. But if you have an individual other lens of the same type, very often they're slightly different. And then we provide you with it's an Unreal game that you can load and basically tweak the lens parameters to your particular ones. And that actually works really well. Most virtual studio providers have interfaced to our technology, and yeah, it works.
Okay,
fantastic.
Thank you, Michael. So if we follow the logic of the pipeline, we talk about the hardware, we have the tracking of the head, we have the lens is calibrated. The next step would be the software, and to render scenes realistically, you need a powerful render engine. And that's why we invited Andy from Unreal Engine to talk about Epic and Unreal. Hi, Andy. Hello.
Hello. Hey, everyone. Nice to meet you. I'm Andy Blondin. I'm with Epic Games, and we make the Unreal Engine. As Michael and others mentioned with Mo-Sys, that it's a powerful graphics engine used for both games, but now for many other use cases, and one of them being broadcast and augmented reality and virtual sets. So I'm here to talk a little bit about it. A bit about myself. I'm a senior product manager at Epic Games. I worked in the broadcast industry for 15 years and then made the move over to Epic. There, I was a motion graphics design director at Fox Sports and very familiar with augmented reality and virtual studio solutions. And now I'm at Epic and help run the product side of things of which feature set we need to put into the engine to make all this stuff work. So next, I just want to play a little sizzle reel showing off some of our integrations and the client work that's been done. So I'll go ahead and play that. Cool. Well, that is a little bit of the graphics. And as you can see, there's lots of augmented reality in that sizzle reel, lots of clips where people are utilizing the engine for live broadcast. And today I'm here to talk about virtual events and where it could go. I want to talk a little bit about Epic Games. So we were founded in 1991. We've been around for 30 years. We're award-winning global firm, and our headquarters is in Cary, North Carolina. And but we have a global footprint all over the world. A little bit about what we do. We make, you may know us from Fortnite and making video games, but the software that makes Fortnite is called the Unreal Engine, and that's the other arm of our business. And we also license that engine to other video game makers who make video games, and also enterprise clients that make various forms of software based on that, as Michael mentioned, one of the use cases. So this technology is the same tech that powers Fortnite, which has over 350 million players. So it's built to scale to massive platforms. It's on Xbox, PlayStation, desktop, pretty much every platform out there, but scales to the size of content that you need. At Epic, we have the idea of basically building one experience and having many outputs. So you can output still images, interactive experiences such as a game. It could be a LED volume or a VR cave like we did in Mandalorian, or it could be augmented reality or broadcast like some of the clips that I showed earlier. And some of the tools I want to talk about inside the engine that you have at your fingertips is LiveLink, which is our API for bringing in camera tracking data. So Mo-Sys has made a LiveLink plugin that allows the engine to receive the data from Star Tracker and from the remote heads that he's talking about, and drive the virtual camera in engine. That's kind of one of the core critical things that we need. We also can ingest the timing of that. So through timecode or through Genlock and Sync, we can use timecode to frame accurately offset those in time. And so those are key critical things for broadcasters. We also ship a Blackmagic and AJA plugin with key and fill and up to 4K outputs that allow you to do all this cool stuff. And we have tools in the engine for multi-user editing. So when you're building something like a game, it's not just a single author making a scene, but many people are contributing to building, in a sense, a virtual world. So we have the ability to have multi-user editing at the same time. We have a server in the engine you can launch, and you can have several clients open and all of them seeing the same changes across, which is really handy for any kind of virtual production or augmented reality. With that, you can also record the data into the engine. So if you wanted to do any post-production work or take it out of the engine or record motion capture data, but then play it back live, you have those capabilities through our system called Take Recorder. There's another system that's called Sequencer. It's our real-time animation tool. It allows you to work like a nonlinear editor. You can cut scenes together and kind of rearrange clips. And that's how all of our Fortnite cinematics are made, is through Sequencer. But you can drive those animations at runtime during a live event if you want to trigger those to play some kind of cool animated graphic that you want to put on screen. We also have powerful character animation tools. So of course we ingest many of the typical like FBX and USD and Alembic files, but we're also moving toward a control rig that has posable character and keyframeable animation. And also you can share that amongst crowds. And that's something we'll touch on today, is animation tools kind of built to scale and what kind of users would like to see on screen. One more thing is we have Datasmith, which is our way of importing data in through various DCCs and helping you retain all the data that you need to in the 3D scene. So materials and geometries and lights and camera data can come in through our Cinema 4D, 3ds Max, SketchUp, and many of the various formats in the CAD world. And I mentioned Cinema 4D because that's mostly what the broadcast market typically is using. That's a big plus. If you want to get started, you can take a look at the Unreal Engine launcher, go to the Learn tab, and there's a lot of sample content. There's two I'll suggest. One is the Virtual Studio sample, which has many of those features that I've mentioned before already integrated that you can start playing with and get up and running. And then we also have a virtual camera system, which will allow you to take any iPad or iPhone and use it as a virtual camera and start to drive that around and block out your scene with your characters. And for filmmakers and people who are just trying to test stuff simply at home, it's a very good and useful tool. And so, yeah, thank you very much. I'll hang around and look forward to the Q&A and talking with you guys. So thanks.
Thanks, Andy. Thank you. Yeah, so if you have any questions for Andy, just again, use the Q&A. I bet there are many questions. Okay, so now we have hardware, we have the software. The next step would be to use it creatively. How can we use the power of the Unreal Engine and the accuracy of tracking for our projects? So let's talk to Jerry and Eric from Standing Room Only about their approach. Hi, Jerry.
Hey, how are you guys?
Hello, Eric. Hey, guys.
Hi, how are you, Marcus?
Hello to LA.
Yes, yes.
Jerry, Eric, could you talk us through your project?
Absolutely. Let me do a little screen share here. Get set up. So we are a company called Standing Room Only, and we basically provide real-time simulated crowds for venues around the world. Who are we? Shipping and Handling is a high-end VFX company in Ignite XR. We joined forces together to create Standing Room Only Sim. I am Jerry Spivak, CEO, VFX expert for over 30 years. I joined Shipping and Handling not that long ago, and I'm also one of the founding partners of a high-end VFX company in Hollywood called Ring of Fire.
I'm Eric Ladd. I'm CTO. I was founder and president of the Picture Mill and president of Ignite XR. We created state-of-the-art AR/VR technology for sports, entertainment, and medical clients. Our team has extensive experience in creating realistic crowd simulation for all type of sporting events.
Let me show you a little bit of sample here of how we utilize this technology in our world of broadcast and production. And then this is sort of the springboard that put us into, developing this idea for live sporting events. Here's a little sample of that work.
It's turning out to be a beautiful day in Kansas City. Let's go. It's Mike 52.
I see trees of green, red roses too. I see them bloom for me and I think to myself, what a wonderful world. I see skies of blue, clouds of white, bright blessed day. And I think to myself, what a wonderful world.
So that's sort of a sample reel of the kind of work that we do and the level of work that we do. And then again, why we formed SRO is, when this whole COVID-19 began to impact us, we started thinking, how can we use our vast knowledge in high-end VFX, AR, VR to fill stadiums around the world? Because it's kind of a weird thing to watch a sporting event with no fans. So we wanted to use that technology to sort of bring that to live sporting events.
So we connect the dots. What we do is we take customized crowd simulation plus camera lens data plus camera tracking plus an Unreal Engine plus customized audio, and we get SRO Sim, which is a turnkey solution.
Mm-hmm. So basically, each individual person here has been talking about their own specific sort of piece of the puzzle to make this all work. We are the group that sort of puts it all together in a nice little sort of cohesive way and delivers it all as one nice little package. Here's an example of a still frame that we generated using this technology. We had a stadium, we filled it with audience, and then lit it appropriately with HDRs, and blended them with the scenario of the live action play. Now, another aspect that we felt was really important to this whole immersive experience was crowd sounds. We felt it was really a crucial component to the whole vibe of watching a live sporting event on a broadcast venue. So what we're doing is we're going to do a live mix, utilizing sounds from previous games, sampling from different databases to create a live mix that really follows the ebb and flow of the game and gives that viewer at home the most real and immersive experience that they can, that it feels also as normal as they can. That's the whole idea of this thing. It's not to showcase any crazy crowd or make the sound be anything but what is normal. So that's the whole idea here. And then also, we could take that mix that we're feeding to the broadcast venue and also feed that inside the venue. So potentially the athletes can hear all this, what's happening, as well as the live broadcast. And Eric, take it a little bit farther.
Yeah, and so what we can do is we can add on to that by integrating via a mobile application live fan cheer audio. In other words, people at home can, respond, and we can then mix that in and pipe that into the live venue and the broadcast stream. So that adds you the customized momentary sound, so that they're connecting to the actual events in the game. So with that, we're able to do a little bit more customization and make it a little bit more personalized to the specific game.
Exactly. Now, what about fan engagement? There's a couple other aspects about fan engagement as well. You know, sponsorship. I mean, this is going to be a whole new opportunity for sponsorship and integration with sponsorship within the sports venues, as well as using that and cross-platforming that with digital media. Just think about all the possibilities, AR, broadcasting, and that brings to the scenarios that you've been seeing through us and all the other participants here today. So the creativity can just fly off the charts here in the next few months as far as the ability and utilizing this technology.
Some of the digital media we can also do is adding in AR activations that are mobile-based and social media-based. We can also add a super fan app, which literally is a mobile app that you take photographs of your face, and those images can be placed within the crowd so that it's more personalized and up to date. So that's just an opportunity that goes above and beyond your typical, CG fan interaction.
Yeah, I mean, think about, a super fan having the ability to sit home, scan their face, and then watch the event in the venue and see if they can find themselves in the crowd. A pretty unique sort of way to engage fans in a different level.
Absolutely.
To kind of summarize up here and not take too much more of your time, we're basically combining different emerging technologies together in a unique way to create crowd simulations for live events, multiple cameras, fan viewing experience, and just really kind of enhance the venue and make it as exciting for the fans as they're really used to, and they need to be get back to as normal as we can. So that's what this sort of process is trying to bring to the prize.
So thank you very much for listening to us. And if you want some more information, you can contact us with the email address below, contact@standingroomonlysim.com, or the phone number. I'll be glad to answer any questions in the Q&A section. And thank you to the Mo-Sys people for allowing us to participate. We really appreciate it. And back to you.
Thank you, Eric. Thanks for this.
Thanks, guys.
Great presentation. Thanks, Jerry.
Thanks, guys.
So the contacts, I will put them up at the end of the webinar, so you have time to just take a screenshot or write them down. Whilst we were talking in the last 10 minutes, you can see I'm alone in the lab here. So Michael made his way up to the second floor. And if everything worked okay, he should be joining us on his phone now for a live demo of the V70 tracking kit. Michael, can you hear me?
Yes, absolutely.
Fantastic. We can't see you, Michael? Oh, there you are.
Yeah, okay. Hello. Let me hand that over to Alex. Yeah, this one. Okay. What? Oh, wait. Okay, fine. All right. So what we have here, it is London and it is raining as usual. So we actually set up everything for you on the roof, optimistically, looking down, because we wanted to simulate a sort of stadium-like situation from high up, and you look down, and then suddenly it got so windy and rainy, and we just today just pulled it all down and quickly set it up in here. So we're a little bit limited with our movement. We're looking out of a window instead of having the whole panorama on the roof space. I would have loved to show you that. Okay, but here we have the car park now filled up with lorries. They're building film studios here, by the way, so soon. And here we have a little bit of virtual audience. I don't know if you can see that. I'm shaking the camera a bit more to show you the tracking. Yeah, and so yeah, we actually don't want to sort of get into creating assets. We just do a little bit to show you the tracking or our technology or our Unreal plugin. We leave the content creation to other people. So that is just to demonstrate here where you are. So let's zoom out a bit. And yeah, we see some logos that are actually not there. And here's another logo. So we're trying to use the space and add some augmented reality into that space. So, you need to have good lens calibration, otherwise the people, the virtual people here would drift relative to the sort of concrete, and they don't. And you will see this primarily sort of in the corners of frames. Yeah. So this is just to demonstrate, but you could easily replace the augmented graphics here with audience in a stadium, and
Yeah.
I think that was it. It actually, I think, comes across very quickly. I don't know what else to do here. So, Marcus, if you start with the question and answers, and I'm going to come down in a minute and join you.
All right. Thank you, Michael, for this demonstration. Yeah, so we're going to open up the floor for questions. Please feel free to use Q&A. So let's start with the question for Andy. Andy, are you there?
Yes, I'm here.
Hi, Andy. What Unreal tools help me create AR graphics is one of the questions.
Sure. I tried to cover some of them in the intro, but the core of augmented reality is building very good, scenes, being able to bring in the 3D models. We support a lot of different formats, so you can do the FBX, you can do. Now we're doing USD, which is a kind of more advanced format. And so, really the sky's the limit in terms of what you want to build and artistically. As far as the tools go, we work a lot with Mo-Sys and the tracking providers to make sure that, as everyone mentioned, that the lens calibration is really good. The tracking information is really good. There's no kind of drift or any issues with that kind of stuff. But really the core of good augmented reality comes down to matching the lighting. And so Unreal has very powerful tools where you can capture an HDRI of the current environment and you can feed that into the system so you can use that to light your characters. It's always good to have soft shadows if like you're in an environment that needs soft shadows, for example, and matching kind of the color, temperature, and balance, the correct exposure, all those things to make it look very integrated. And that's where I feel like Unreal's very powerful. Also supports like depth of field and bloom and all the type of effects that really help sell the composite.
Thanks, Andy. Question for Carlos. Can you talk about center shift? Is there anything that the lens compensates for?
It's the same question we had this morning.
Mm-hmm.
Yeah, we were talking about that this morning because someone asked exactly the same. Of course, is it possible to find some this adjustment in the optical axis of the lenses? And if you move the zoom from zoom in to zoom out or all the way around, you can see how the image is moving from right to left or in diagonal, or the center of the images is not keeping the same position in all the focal length. For sure, this will affect to the possibility to add some images, virtual images. So it's possible to adjust. We were discussing this morning about the manufacturer is putting some limitations or specification in the margin we have for the adjustment of the optical axis, and we can readjust this optical axis by moving the mount in the workshop, in the optical workshop. So it's possible to readjust mechanically this optical axis. I'm not completely sure if you from Mo-Sys can also change a little bit this position of the optical axis.
Yes, yes.
Virtually.
So we initially for our lens calibration we calculate the center shift, but then on set, because the center shift it's very sensitive, so it can change when you take off the lens, put it back on, or you can just change the weight of the lens or the temperature changes.
Yeah.
I've seen it at the Red Bull Air Race. It was like the temperature changed by 10 degrees, and we had to readjust the center shift. So it's very sensitive, and
Yeah.
we also have like a tool where you can just dial in the center shift.
Yeah, it's ideal to have the optical axis adjusted mechanically in the workshop. And if you have a small difference from tele to wide, then probably you can compensate by your device.
Yeah.
But if originally the optical axis has a very big disadjustment because of the position of the mount, so then it will be possible, it would be impossible to readjust from your system.
Mm-hmm. Mm-hmm. Okay, thank you.
You're welcome.
Question for Jerry and Eric. Jerry and Eric, how do you deal with different teamwear, different sportswear? So if you have different teams, how do you simulate the different colors of the teams?
Yeah, I mean, that's pretty straightforward in our world. I mean, this is all very customized to each venue because the seat layout in each venue is a little bit different, the rows, all that kind of thing. So once we do that layout in wardrobe, everybody, I mean, changing colors is not that big a deal. We would sample sort of other and look at other venues that how they've played and kind of match that attitude as far as the number of colors in the home team versus the visitors. And yeah, that's not a big deal at all. Swapping that wardrobe out to be more of a home team scenario.
Including branding, of course.
Yeah, right, exactly.
And this includes audio because every team has their own chants.
Exactly right. I mean, every sport's a little bit different too. I mean, baseball sounds a little different than baseball, than football, than basketball, than soccer, than rugby. I mean, everyone's got their own sort of sound and sometimes each, like you were mentioning, each venue has a little unique sound, chants that they work on and things like that. So all of that stuff will have to be customized and for each venue. So obviously the end goal here is for each of these venues, for the viewers to just feel that it's just all natural, not drawing attention to the audio, not drawing attention to the people. It just all sort of just needs to meld together like normal.
And without an audience, you know, you hear one guy clapping, it's really odd and off-putting. And when you see a pan of a bunch of empty seats, you know, a swash of empty seats as background, that's really also ominous and off-putting. So, you know, our goal is to make it feel natural and organic.
Right. Okay. I think the next question is also for you. What is the production time for a live game with crowd?
I'm sorry, can you repeat that question again?
Yeah, what is the production time for a live game with crowd? I guess this includes like pre-visualization and yeah, previs, and then the action.
I'd say it kind of depends a little bit. Some assets for some stadiums are available to us and we have already. Some venues we need to recreate and do a LiDAR for this, for example. So really, some of it depends upon the assets that are available to be given to us and how fast. It's basically the scenario. So specific time, it's hard to say. It could be 2 weeks. It could be 6 weeks. It really depends upon the venue, the ask. Certain sports are going to be more difficult than other sports. The layout of the venue. There's a lot of variables, but it's not like we're talking like many, many months to get this up and rolling. I think we're more in like, weeks,
Right.
Yeah.
Okay. And there's another question for you guys. Curious what rendering platform you guys are using for these crowds.
Well, obviously we run everything through Unreal because it's part of the workflow that Mo-Sys uses, and some of the other software packages that we use. We have experimented with zero density and some other packages, and we basically, without getting into any more greater detail, we use what's the most appropriate for the specific application.
Okay.
Can't give you all the secret recipe on the call. You know, I mean, some stuff's got to be behind the curtain a little bit.
Okay. Question from Michael. Are you still up there?
Yeah. I thought I'd stay up here.
Right. I was wondering right now. Okay. Michael, how are the AR graphics aligned with the real world? What are the...
In this case here, we sort of measured the car park and how far the building is away. And then you can also guesstimate a little bit by, you can also, in a large situation like here, you can also go to Google Map and measure it out, where your areas are, or like Jerry and Eric was saying, you could do a LiDAR scan and then you know where you are, should know where you are, and put your AR graphics in the right place. Now, another thing we do is we have a method, especially if there are several cameras there. So, I mean, one thing is to find the place of the camera. And the second thing is then to put your AR graphics into the place. Plus, but you find the position of the camera by having on your field, soccer field or whatever, we have a special sort of pattern that we move, and that calculates the position of each camera. And once the position of the camera is found, it's quite easy to then put the AR graphics into the right place.
Okay. I guess this question would be for, well, Michael, yeah, how can we convert the data from the tracking head to the compound? What are the ways the tracking data is transferred?
Okay, we have several ways of connecting all of our devices. The basic one is the Mo-Sys bus, and this is something that connects all of our devices together in a daisy chain manner, and the maximum length there is 100 meters. Then you can also connect, let's say, your camera to your input via radio. That gives you like 500 meters. Ethernet, I think it was 500 meters. Then we also have fiber. Fiber goes up to 20 kilometers as a single mode. Then we can connect over the internet, but you start having delays and you don't know where the signal is going to if you don't have your own private line, which means the delays are uncontrollable. The next thing what we do is something called timecam, and timecam has then means of compensating for the delay that you have going through the internet.
Yeah.
So there are different ways depending on distance and delay.
Exactly. So on timecam, we will have a separate webinar in the near future. Okay, so the next question, I think I'm just opening up for this one. Can you separate objects in the foreground, like balls or players, from the background? So maybe Andy or Jerry and Eric.
Yeah, I can try to take a stab at this one. I mean, there is a complex topic. If you look at things like, say, the NFL, for example, they obviously put stuff on the field that's like a first down marker that can go behind the players themselves. You need a similar approach, I would say, if you have a sport. Depends on, you know, if that ball is going to be crossing into the crowd area. That could either be keyed or could be segmented in some kind of a way through, you know, image analysis or kind of tracking. But obviously embedded in the video that's coming in will be the ball in certain cases. I think for the short term, you'll see potentially camera angles change to help kind of suit some of this. And long term, I think it kind of gets to what Michael was pointing at earlier, was that this will open the door for lots of creativity, I guess, to come out of natural constraints. So I think we'll start to see unique solutions for solving these problems. But yeah, it's one of those known issues, I guess, with the current.
Yeah. So
Andy, we agree with what Andy said, and in addition, there's a whole strategy behind how this is shot, and there's some slight camera angle changes, etc., that mitigate a lot of the issues. So that's another way to look at it.
Cool. Okay. I think we reached the end of the questions. Let's check. Oh yeah, where can we see a demo with a 3D crowd render? When will it be ready to show up publicly?
Well, we can show you a demonstration if you contact us directly with the contact information at the end.
Okay. This is a question for Andy. Can UE4 create front plate AR assets along with backplate environments for one scene from one server, or does this require multiple UE instances?
Yeah. So yeah, in the vanilla engine, you can do this currently. So we have a system I didn't mention. I actually took the slide out, but there's something called Composure. And Composure allows you to bring in a video feed. You can do the green screen keying on it, and you can have a background all coming out of one server. So all in one box solution. They did mention some of the other kind of implementations are built on top of Unreal as well. So we work with Zero Density and Pixatope and Ross and VisRT and all the players, and almost every solution there's a strategy for this. But typically, yeah, it's like one render engine and one video feed coming in that's either keyed or composited in AR. So.
Mm-hmm. Okay, cool. So if there aren't any more questions, which there aren't, I think we can wrap it up. Thank you so much to the speakers. Thank you for your time. And
thank you, everybody.
Thanks, Michael, on the roof, on the second floor.
Thank you, Mo-Sys, for setting it up.
Yes, thank you.
Thanks for inviting Canon, Mo-Sys.
Yep, thanks very much.
Thanks everyone, and thanks to the viewers. I'm just going to pop up the contacts at the end. I will leave it on for a minute, and see you next time. Thank you.
Okay, bye-bye.
Bye.